Sir, our mid-sem exam is held on Moodle.
Next week we will say something and mixed way. Some students will sit in the module, some students will sit some other places. We will let you say later. Now.
Okay, sir.
I'm just. I'm not allowed to talk to you now. I'm just opening your microphone. I'll give you time later on. If you need anything, want to see or want to say, you just write in chat box. I'll let you see. So I'm opening your microphone. You can't talk now. I'll allow later on. Too much lag in module. Yeah, we know. Whatever, I'll talk to you later on regarding that one. Okay, so now let us. Anyway, due to your this school class was by Professor Anita Pal, but due to some unavoidable reason, she is unable to attend the class. That means she is unable to discuss with you. So that's why yesterday we have rescheduled. I am here and I don't know tomorrow who is going to take a class. Maybe me or maybe other faculty. So we'll let you know later on. And since I am teaching here, so last classes I have just discussed with you beta and gamma function, and you have learned these things. Remaining another 3 classes I am going to conduct with you. That's mainly application of definite integral, and almost if you see my assignment already given, almost everything is given without solution. So you need to, and some formulas are given. Mainly there are 10 formulas or 10 formulas total. Almost some are dummies. That means if you know one, you can remember another one easily. And some are already know. First 2 are very basic formulas. Just one. Anyway, and so you and the proof of these formulas are not required, but I am giving some sketch of the proof so that you can remember easily the formula. That's the issue. And if your exam is online, then you know that you will remember this formula or not. But keep in mind, you in future you need these formulas. So you try to remember or try to understand these formulas. Fine. So that you can and how we apply this formula, you should know. So let us start. First formula you know, and to solve this application of definite integrals, suppose I am giving any problem, you need to first try to figure out this problem. That means you need to try to draw or at least imagine the graph of the picture, so that you can where we actually going to solve. That means actually we are going to do 3 things, we can say. First one is the integration. So we are going to do application of definite integral. That definite integral, improper integral we have discussed. Definite integral means the limit is finite and integrand f of x. That means common integration is something like this: integration over a to b f of x dx. Definite integral is if a and b are finite, then and f of x is continuous, then we call this is definite integral. And we know that this definite integral has the finite value. That means, and graphically we already discussed this one. If we draw this curve, this is x-axis and this is y-axis, and we plot this curve f of x, that means basically this is y equal to f of x, then this integration gives something like this is two straight lines. The graph is not too fine. So this is x equal to a, and this straight line is x equal to b. And this integration gives this area. The area under the curve y equal to f of x above the x-axis, bounded by two straight lines x equal to a and x equal to b. This area. So that's we are going to find area bounded by two straight lines x equal to a and x equal to b under the curve, continuous curve y equal to f of x above the x-axis. This integration is you all able to solve this integration and depend on the f of x. Then the value of this integration gives this area. So first problem is actually we are going to find the area bounded by some curves. But this example is very easy, but sometimes this curve may be like this, then it's difficult. So suppose curve is something like this. Then how do you find the area bounded by this curve? So this is something like this. At that time, this is somehow difficult, but we should learn something, some easier process or some. And second problem is, suppose any curve is given, similarly, what is the length of the curve? So something like this. The first one is we are going to find number one, area bounded by this. Number two, length of a curve and number three, if this curve that you say if this curve revolves about x-axis, something like this. So keep in think about this first figure. This is x equal to x-axis and y equal to f of x, a curve, and this curve is revolving around the x-axis, along the x-axis. That means fixed distance from x-axis, we are revolving 360 degree. Are you clear about that? We are revolving like this x-axis. Then you see, and if we take this x equal to a as a plane, that is in 3-dimension plane, and x equal to b, if we take the plane parallel to yz plane, and then you see we are, and the above curve we are getting some volume. So that volume we are going to find, and we are getting some surface. That surface we want to find. So next is number 3 is surface and volume. So including today remaining 3 classes, we are going to discuss these 3 things: area and length of a curve. Today I am trying to complete this number 1 and 2 and only formula with some example. And another class, next class, we will try to complete the surface and volume. So keep in mind, I am giving some formulas. That formula only you need to remember the formula, and then you need to learn how to apply these formulas. That's we need to learn. So let us, and first thing, area, you are clear about that. But okay, parallelly, we will learn here 2 things. So if the curve is 2 types, that is y equal to f of x, we call this is that means whatever we have drawn, this is x-axis, this is y-axis. We call this is Cartesian coordinate. Cartesian coordinate. And another is polar coordinates. So you are familiar with that, r equal to f of theta. That means if the curve is in the form of r comma theta, then we call it is polar coordinate or polar form. Okay, and I hope you are familiar with this. That means if it is Cartesian, that it is x-axis and y-axis, and if it is polar, then the polar form generally we denote it by initial axis. We called it is not x-axis. Keep in mind, when we are talking about polar form, then this OX we denoted by initial axis, and we take a length. Suppose any point here, we take this length is r, and this point we denoted by r comma theta, and this r is the length from origin O, and this point is called origin O point this, and theta is the angle from positive side angle with respect to initial line OX. So this angle theta. So this is the polar coordinate form, and that previous one is the Cartesian coordinate form. So whatever we are going to find this area, length of a curve, surface and volume, we'll just two cases we'll learn. One is Cartesian coordinate, another is polar coordinate. So now, okay. So first formula number 1, it is given in the assignment. Everything written in the assignment. If you want to write, then fine. But everything I have already ready-made. I already gave you. Now the first formula, you know. Suppose we want to find the curve. This figure, formula number 1. I am not writing again. Suppose we want to find the area bounded by the curve y equal to f of x, and the bounded by two straight lines x equal to a and x equal to b, and above the x-axis. Then what is the area? This area. So this area is the formula is this one, integration over a to b f of x dx. You know already how this formula came. So we denoted by a here, a equal to, this is number 1 formula. Fine. In Cartesian coordinate, the area bounded by the y equal to f of x under the curve y equal to f of x above the x-axis and bounded by two straight lines x equal to a and x equal to b is the area. That area gives actually integration a to b f of x dx. And now suppose the curve is something like this. So we need to learn something more. That means this. So if so, let us check it. Suppose the curve is something like this. Okay. If the curve is something like this, and suppose x equal to a and x equal to b, so x equal to a and x equal to b. If we want to find this curve, can we find this area using this formula, integration over a to b f of x dx? The answer is really no. Answer is no. Why? Because here you see the, be careful here. If we take any point here, x equal to c in between a and b, this and this curve, that means this line x equal to c, it is touching the curve twice. That means here this one and this one. So this will not allow. That means curve should be continuous positively, and it should be the single valued function. This, and for single value y, x equal to c, y value of y gives the double value, and that is not suitable to find the area. And that case, we need to consider something else. So how can I do? So something like this. Suppose the curve is something like this, then or like this, then we can take actually with respect to y. We can integrate. That means in this curve is the single value with respect to y. So if we consider y equal to x equal to f of y, we can just take opposite, x equal to f of y, and for single values of y, the x gives the single value. Single values of y, always x gives the single values. In that case, we can find the area y equal to c, y equal to d. So what we are going to do, the curve here, origin, this is x-axis, this is y-axis. What we are taking here, suppose the curve is given x equal to f of y, and this is single valued. Single valued means for single values of y gives the single value of x. Then the area under the curve x equal to f of y, right side of the Oh, sorry. Maybe somehow internet. Is it fine now? Someone write, please. Is it fine? Ah, okay. Okay. Thank you all. Fine. Please don't write. Somehow I was disconnected. I'm unable to see that one. Sure. Yeah. Thank you. Screen I have not shared. And now you can see my screen. Is it? I hope it is fine. Let me allow. I have allowed your microphone. Is it?
It is visible and audible.
Fine now.
Okay. Okay, good.
Yes, sir. Now it is visible.
So I don't know where I
That
have
is fine, sir.
disconnected. Okay.
Audible.
Sir, is calling.
Sir, please start from the function x equal to function.
Okay. Anyway, so I repeat something. I don't know where I have disconnected, but still just whatever I have written, you may see I have written up to this. So our target was this one. We want to find these three things, remaining three classes, including today. And this formula you know, A equal to, so if we want to find this area under the curve y equal to f of x and above the x-axis, bounded by two straight lines x equal to a and x equal to b, this area gives this one, number 1. Fine, this number 1. And now, if the curve is, that means single, not single valued, something like this, that means for single values of c, we are getting single values of double value or more than one value of y, then in that case we can't apply this this integration to find the area, integration of a to b f of x dx. So in that case, if possible, we can just think another way. That means this curve is, suppose we are taking x equal to f of y. In this case, we can take also. If we take x equal to f of y, then we can integrate with respect to y. And then in this area, that means suppose two curves, y equal to c and y equal to d, and the curve is x equal to f of y, then this area A is, we can do integration over c to d f of y dy. So major important part is that you need to check, that's why I have said that any area, this application of definite integral you are trying to do, you need to draw first figure. So you need to understand that where we are going to find, that means which area we are going to find, or which length of the curve we are going to find, and which surface or volume we are going to find. So before that you need to figure out the shape. Okay, what is the shape of the curve? And I have said that two types, so these two formulas are for Cartesian coordinate. And what is the formula if the curve is given r equal to f of theta? So sometimes actually keep in mind, so you have learned just previous 3 classes from my side. You have learned this, the integration, so many integration we can't do. Whatever you have done class 10 plus 2, you have thought that, oh, we are doing so many integrations. But the main thing is that you have learned only few integrations, how we integrate. And that is actually called analytic solution, analytic integration you have learned. But outside of your region, there is huge differential equations or integrations so that we can't solve. To solve that type of integration, we need numerical method, different method. That means numerical means we are getting not exact solution, but near about the solution. Fine. Like this, here so many type of curves we have, so we can't find the area. But whatever we are learning some basic curves so that we can find the area. And sometimes in the Cartesian coordinate is difficult to use this formula. So that type of case we can apply the polar coordinate. So polar curve is sometimes suitable. So that you need to learn. So suppose curve is given, we should use polar coordinate or we should use Cartesian coordinate. And you know that we can frequently move from polar to Cartesian and Cartesian to polar with that formula x equal to r cos theta and y equal to r sin theta. From that relation, we can move from Cartesian to polar or polar to Cartesian with some certain conditions. Okay, so now what is the formula? So these two formula you are clear. So area bounded by this curve is this formula you already know previously, and bounded by this area gives this formula. Now if the curve is something like this, r equal to f of theta. So it is called polar form. So then, so something like this, whatever I have drawn this curve, this one I am repeating again. So some is one initial axis OX. So when you are talking about polar coordinate, you don't talk this is x axis. You should say this is initial axis. You call it is initial axis. And suppose a curve like this, we are taking our suitable curve, r to draw nicely, f equal to r f of theta. And now suppose we are taking, we want to 2 points here, alpha comma r1 comma alpha. So this is the angle alpha and this length is r, and this is another point, this is beta comma r2 comma beta, and this is angle beta. Fine. And suppose we want to find this area. So bounded by the curve and two lines, R1 and R2. Okay. So what is the formula for this one? Area, this area A equal to half integration over alpha to beta r square d theta. So if we say that how this one came, this is alpha, don't infinity. So keep in mind, you don't mix alpha and so we see too many times. So many students writing like this. Alpha is like this, and infinity is like this. That means infinity is going to meet, and this is alpha. This is alpha, and second one is infinity. So don't mix these two letters, because this type of problem we feel difficulties. So alpha is first one and infinity is second one. And how this formula we can do, we need some idea. Okay, so one way is that we can from Cartesian coordinate we can put, but we need some manipulation. Okay, anyway, I'm not going to details how, and so try to remember this formula. This area, how to find this area. This is half into alpha to beta, and the theory I have written probably how this came. Oh, not this one is not written in the assignment. Anyway, so these two formulas you need to remember, and you need some actually extra properties. And next, suppose we want to find the length. So something like this. So this is number 3, formula number 3 according to assignment. Yeah, and number 2 is this one, and number 1 is this one according to assignment. These 3 formulas we need to understand and remember. Second, we are going to give another 4 formulas. So The four formulas is almost similar in Cartesian and polar. So length we are going to discuss length of a curve. Length of a curve. Now, similar way, this is x-axis, this is y-axis, this is origin, and a curve like this, y equal to f of x. Now, suppose any point here, x1, y1, we can write like this. The point is x1, y1, x1, y1, and another point is x2, y2. So we want to find the length from this point to this point along the curve like this. Okay. So this length we denoted by capital S. So to do this, the formula you can remember easily. One thing is that the small figure we are just any position if we take here, we can think like this point. Suppose this curve is moving from this point to this point, and this is a length from simple small point we are denoting by ds. And for moving from this point, we are denoting this is dx. And after moving dx, y is changes to dy. So this this position, if we do bigger, okay. If we do bigger, we are getting like this. So this position, something like this, we are getting dx, dy, and this is ds. So in very small case, we can consider this is a triangle, right angle triangle. This angle is 90 degree, right angle triangle. This is dx, dy, and ds. So this small case we can consider like this, and since it is a small case, we can from this we can get the relation this ds square equal to dx square plus dy square, and some people know this. And so the length, you see, if we do integration over ds, we are thinking like this. And if we take that integration, so if we take from this point to this point, we can take something like this. If we total point, that means total length we find, we integrate and sum x1 to x2. And since we are taking the limit x1 to x2, we need to integrate with respect to x. So we manipulate here a little bit. How do we manipulate? So this equal to see integration over x1 x2 ds means from here we can write under root of dx square plus dy square. Still we have not ready to integrate. So here from here we can just simplify and forcefully we integrate like this. Since our target is we want to integrate with respect to x, so we take dx common forcefully. So if we take dx common forcefully, we are getting like this 1 plus dy by dx whole square dx. So this is the formula, and now you can, since the curve y equal to f of x is given, this curve is given y equal to f of x. So we can derivative it, since we are considering that this is continuous and differentiable. So we can derivative and we can do this integration. So this gives the length of the curve from this initial point x1, y1 to x2, y2. And sometimes this integration is little bit difficult with respect to x. At that time, from here we manipulate. So this is formula number 4. Formula number 5. Sometimes this integration may be difficult. At that time we can integrate with respect to y, but the length will be the same. So what we will do? We just start from here or we can start from here, just integrating with respect to y. So suppose we want to integrate with respect to y. So then this S surface area arc length. Oh, yes, we have written S integration over y1 to y2 and ds. Again, we are starting from ds, and ds means under root of this dx square plus dy square. And since our target is we want to integrate with respect to y, so this equal to, and this if the curve is given that y equal to f of x, then integration over y1 to y2, we take firstly y dy common. So we are getting 1 plus dx over dy whole square dy. Yes. So this is formula number 5. So actually S equal to, this is the formula you need to remember, and this is number 5 and this is number 4. Fine. This is number 4. So this gone for Cartesian coordinate, whatever we want to integrate with respect to x or integrate with respect to y. What about if it is polar form? So to do polar form, you need little bit. Again, we can move from, so number 6, if it is polar form. That means if the curve is given r equal to f of theta. Fine. So you know, just starting point, we have said that there is a relation x equal to r cos theta and y equal to r sin theta. This is the relation between Cartesian coordinate and polar coordinate. Suppose this formula is given, that means this we know. So how do we handle if it is in polar form? So this also detail given here and here. So let us just write something. Suppose here x equal to, it is given r means f of theta sin cos theta, and y equal to f of theta sin theta. And if we derivative with respect to theta, this both dx d theta, we are getting, I hope, a partial derivative. Little bit something like this, but no. So you can apply something x y. That means this is x u v formula, something like this derivative. What we are getting, f of derivative of this first part f dash theta, I hope you know, into cos theta plus f of theta into derivative of cos theta minus sin theta. Fine. And similarly, dy over d theta equal to, we are getting f dash theta sin theta plus f of theta cos theta. And if we do, if we square both, square of this, that means dx d theta whole square plus dy d theta, that means squaring and adding, we are getting square and adding and simplifying, we are getting r square. You can check easily, r square plus dr d theta whole square. Fine. Now our idea from this, that means our main idea from here, we just going to do the in polar form. That means from here we are changing to polar form. How can we change? So still, suppose we did this one, s equal to without limit. Suppose we are writing without s equal to integration over under root of dx square plus dy square. And see, in our hand, dx by d theta whole square plus dy by d theta whole square, it is in our hand. So what can we do? This equal to, we are taking again forcefully common d theta. So integration over, if we take forcefully common d theta, then we are getting dx d theta whole square plus dy d theta whole square, and this d theta is outside. And since we are going to integrate with respect to theta, then we will write theta equal to what I have written before. Oh, I have not drawn any curve. So anyway, so you can think like this way. We have given, yeah, polar form. So something like this. Suppose we want to find in this graph, we want to find this length of this curve. Then it is given r1 alpha and r2 beta. So since we are going to integrate with respect to theta, so we should write limit should be alpha to beta. So here the limit should be alpha to beta, and this equal to, you see, just we have done this one here. Yeah, this relation, this one we want to write in terms of r and theta. So this is equal to r square plus dr d theta whole square. So this equal to, you can write integration over alpha to beta. This is alpha to beta under root of r square plus dr d theta whole square d theta. So if the curve is given r equal to f of theta, we can put in this equation in terms of this automatically converted to r in terms of theta, and we can integrate. The integration value is the length of the curve. Fine. This is the formula, and similarly you can just last one. This is formula number 6. I'm not going to discuss 7. In terms of, from here again, just little bit manipulation you can get. If we want to integrate with respect to r, we are getting integration over r1 to r2 under root of, here should be dr inside 1 plus r square d theta dr, r square d theta dr whole square. So this is number 6 and this is number 7. These 7 formulas, and another 3 formulas we will discuss next class. These are the formulas. I thought I'll do some problems, at least one problem I can do. In our hand we have 6 minutes more, so let us discuss here. I have stated in the assignment, see, first 3 formulas 7 problems, and last 4 formulas 9 problems you should do. But here some curves are you are probably don't know cardioid. I have not given probably full assignment to you, and my full assignment in the last these curves are given actually. Oh, I should fit here. Anyway, you see in the Google, suppose cardioid, what is the shape, and first you try to draw the curve, and then you try to find the area or length. So now in the assignment first problem, it is given, I don't know, it is just 1 minute. If this assignment here, yeah. Can you see problem number 1? Suppose we are going to solve this one. It is easier one. I should just unmute you. Oh. Can you try this one yourself? Find the area of the region bounded by the upper half of the circle x square plus y square equal to 25, and the x-axis, so something like this.
So 25 pi by 2.
No, answer is given here. You may see. You need to calculate. Yeah. So first I have said that you sketch the graph like this, and the curve. This is circle. So I should take little bit off. Okay, just. Now you think you are going correct way. So something like this. This is the circle. This is circle, and this is x-axis. This is y-axis. Fine. And this is origin. And it is given that x equal to -3. So radius is 5. You're clear. So this is 5, 0, and this is -5, 0. So and it is my x equal to -3 means something like this line. X equal to -3. And x equal to 4, like this, x equal to 4. So we need to find the area, this area. Okay. So and according to this first formula you can apply. So it is integration, the formula integration of -3 to 4 f of x dx, and f of x is what here? F of x dx. Here x square plus y square equal to 25 given. So you can write y equal to f of x. So y equal to under root of 25 minus x square. We are taking not plus minus. Minus is lower side, plus is upper side. So we are taking only positive side. So this is actually converted to integration of -3 to 4 under root of 25 minus x square dx. So this is your part to integration. Let me just give you what is the integration here. So we are going to do minus integration over this is the area a equal to -3 to 4 under root of 25 minus x square dx. Fine. Now this equal to, so this formula you know. What is the formula? So the formula is
x by 2.
A square minus x square dx. This is equal to x under root of a square minus x square by 2 plus a square by 2 sine inverse x by a. Yeah. So compare with this and put these values and find the answer. Probably in the assignment, whatever given in the answer, it is should be correct. You may check. If there is any wrong, please inform me. At least either anyone should be wrong, either you or me. Okay.
Yes, sir. Answer is correct, sir.
This is correct. No?
So the answer is correct, sir.
Okay, good. Actually, this answer some of your senior given, and I just
yes, sir, answer is correct, sir.
Oh, good. And my suggestion is, you see, some answers are not given. Here, this answer is vacant. I don't know. So, someone answering, please let me. You may do at least mail or WhatsApp. That I'll do this. I'll put here, and I'll verify later on. Okay. So this answer and this answer, you do this one and please send me. The answer of this one is this. I'll put here. And some answers also not given here. This one is not given. So please. Okay. So any doubt for this number 1? I hope you are able to do.
No, sir.
Okay, good. And the remaining problems are some Cartesian problems, and this Cartesian problem is easier actually. Integration also easy, but you need to understand what is the graph. This heart shape. This is nice curve. You can see in Google. You check. You can know. And my assignment is this is not full assignment.
Sir,
yes.
In the last page is given, sir. In the last page, this PDF only.
Oh, I have given.
Yes, sir.
Oh, okay. Yeah. This is given. Good. This is given and the formula also given. No? Yeah, whatever I have written, this is given. Good. This formula we need. And this sometimes we need. Okay, let us conclude our class with another.
Sir, I have a question, sir. Sir, the duplication formula, sir, where it is used, sir? Duplication formula. The duplication formula, sir. in the beta gamma function.
Uh-huh.
Sir, where it is used?
That nice question. You will know the answer remaining 3 years. Everywhere actually in engineering, mainly beta gamma function is used for communication system. That means what I want to say. That means this we are communicating. No, the signal is sending from here. You are receiving from your side. So many engineering side is there, but the theoretically that means if you think how it is works or how you manipulate, you need to apply this beta gamma function or actually
No, sir. I am specifically said about the duplication formula, sir.
which
Duplication.
which
Duplication formula.
Oh,
Duplication.
duplication formula. Okay. No, that duplication formula, if you know, then you can solve some other problems using that one. And that is the easier. Any formula is helps to solve some other things. You can.
Okay, sir. Thank you, sir.
Okay.
Sir, is theory part is involved in this note, sir? Today theory part.
So yeah. You see, I am just scrolling, and this theory part also written. Yeah, whatever I did, you see this one I written. And this formula you see, this is 7 formula, up to 7 formula I did. This one is completely written here, this one. And these formulas are, there is no wrong, because so many students checked it. Last 5 years I am giving same type of formula, a little bit after moderation. So hope there is no wrong. Still, if you feel any guilty or any wrong, please knock me, because I can correct it. So you see, this all these things are given in your write-up. Okay, so our main target is this 1.2, that means application of definite integral. 3 classes I have completed 1 class, and remaining another classes I will finish the theory part, and and last class we'll do some more exercises. Okay, let us conclude today's class with another example with maybe time off, I know, but just this one. Can you think about this? Yeah, already this PDF in your hand. You just scroll it. Okay, I am showing that where you can see.
Sir,
Yeah.
can you prove, sir, area part, sir? Area part in polar
No,
coordinates, sir.
everything is there. You just scroll it. Here it is given. I just before previous classes, if you go, PDF I upload. Yeah, you see. You uploaded at 29 January. It is.
Sir, the assignment.
No, it is 29th December. I have uploaded. You can see.
Sir, it is also available at the file section, sir.
Yeah, it is available in files. Anywhere, it is available. But sometimes I'm a little bit moderate. I do, and I exchange. Okay. Anyway, so come back again. Can you solve this one? The answer is not in my hand. If anyone solve, please. So at least can you figure out? Find the length of the arc of the parabola y square equal to 4ax. So first I have said that you try to draw the curve. Y square equal to 4ax. It is common. Y can be negative and positive. So the curve is like this. Okay. And it is given 3y equal to 8x. So that means
Line passing through the origin.
Passing through the origin, and if x positive, y positive. So something like this. Okay.
Sir, you are not audible.
Yes, sir.
Sir, I got disconnected, I think.
Should we leave?
सर ने क्या लीव कर दिया?
सर ने फिर से डिस्कनेक्ट मैंने लीव कर दिया।
कॉलेज खुलने वाला है 3 फेब से।
नहीं खुलेगा भाई, नोटिस आएगा।
इतना तो नहीं खुलेगा।
इतना जल्दी नहीं खुलेगा। 15
खुलने
डेज का
वाला
तो
है।
टाइम आने के लिए।
Wait, please.
सर कॉलेज कब से खुलेगा सर?
Please.
ओए चुप कर,
Class is going on. Somehow I was disconnected. So please wait. You have another class, I know, at 10 o'clock. So what I am saying, at least I am expecting some students will WhatsApp the answer of this question. Okay, you do this one.
Sir, your WhatsApp number?
sir. Yes, sir. Your WhatsApp number,
Sir,
sir.
9.30208.
Official number.
Sir, CA2 will be an MCQ.
कॉलेज कब से ऑफलाइन हो जाएगा?
Yeah, we are expecting your final exam will be in offline.
Really,
sir?
sir?
9.3028.
The final exam means first semester final
Sir,
exam.
CA2 exam will be an MCQ.
Yes.
Sir, final
Mid
exam
sem
means
is-
first semester final exam.
फर्स्ट सेमेस्टर आई हो।
First semester.
Semester exam is offline.
College open, sir?
Depend on the government policy, institute policy. I am not sure what will be going to happen. Let us see. Let us wait and see. Okay. Now, any comments or questions? So, those who want to leave, you may leave. Or if you have any questions, I am here another 7 minutes. Up to 10 o'clock.
semester exam will
be offline.
Okay, sir. Thank you, sir.
Thank you.
Our
Okay.
in-semester exam will be offline.
Excuse me, sir.
Thank you, sir.
Thank you.
Put in the
No, your question is class will be offline or online?
यस सर, अभी न्यूज में आया था
Exam will offline
मेहता
or
मैडम जी बोल
online?
रही थी सर 3 फेब से सब कुछ खुल जाएगा।
Sir,
You
our
are
mid
not-
sem is
First semester, sir. After first semester.
सर ऑनलाइन में उतना मजा नहीं आता है सर।
हाँ सर, फर्स्ट
हमको
सेमेस्टर के
कॉलेज
बाद
जाना है, सर।
समझ में भी आता है सर।
हमको कॉलेज जाना है, सर।
नोटिस आया सर 1 मई को सर
सर सपना था सर कभी कॉलेज